Hi there. This is the third video in a series of videos about analyzing functions numerically. In this final video, we look at an example of a quadratic function. We produce a table of values and we see what there is to learn about that table of values. I've chosen for the example here the formula y equals 3x squared. Any formula that contains x squared as its highest power is considered a quadratic formula or quadratic function. Let's just choose some simple inputs to this function and let's see what outputs it produces. And here goes. 1 squared is 1, 3 times 1 gives 3. 2 squared is 4, 3 times 4 gives 12. 3 squared is 9, 3 times 9 gives 27. And 4 squared is 16, 3 times 16 gives 48. So for inputs of 1, 2, 3, and 4, this formula produces outputs of 3, 12, 27, and 48. Alright. Now the interesting thing here is that if we look at the distance between consecutive y values, we'll see plus 9, 3 plus 9 is 12, 12 plus 15 would give 27, and 27 plus 21 would give 48. Notice these are not the same y values, or not the same differences rather, as was the case for a linear function, so it's not a linear function. It's also not an exponential function because there's not a constant ratio. 3 times 4 gives 12, but 12 times 4 does not give 27. So we're looking at a different animal altogether. If we continue though the process of looking at differences, now we're taking the differences of the differences, we'll see that 9 plus 6 would give 15, and 15 plus 6 gives 21. And now we do indeed have a constant value. The key point to take away here, the key point to take away here is that when you're given a quadratic function, the second differences, which again was the differences of the differences, as we did in the example, those second differences in the y values will be constant. And yet again, if we reverse that statement, we get the idea that a table that has that property has to be quadratic, and that is also true. So again, if you find yourself faced with a situation where all you know is some sample values for a function organized in a table, and if you can ascertain that the second differences in the table are constant like in this example, then you can be sure that you are dealing with a quadratic function. Hope that helps. Thanks for watching.